Yeah, super interesting. If you have time, you have to. Yeah.
following days over our networks. So Fede, what happened in AI this week?
Oof, always happening. A lot of things happening. There was a paper released about chain of thought. Did you read a video more than a paper? Did you read?
Yeah, apparently there is another iteration on chain of thought. Some week ago, we saw this iteration on chain of thought that they kind of did several chain of thoughts, and then they decided which one of those chains was the best response,
Mm-hmm.
and then that was the response of the whole idea. I don't remember exactly the name of the previous paper, but now the last week they released a new paper called Tree of Thought, and it's a generalization of
Uh-huh.
this kind of prompt. And apparently, I don't want to say that that is solved, but I don't I don't have any ideas on how they can extrapolate this further than that. But apparently, these systems are going to get a lot smarter with these kinds of prompts, and we're going to see a lot of improvements in the following weeks because of this new paper for sure.
Yes, every time there is a paper about some of this stuff, is everybody is talking about it, and everybody going to try it, and we will see in a couple of weeks if it's really like they said it has good result or not.
Okay, apparently they can hear me. Audio is fixed now. They say. Okay, yeah. Apparently we can they can hear us now. Okay.
Okay.
Yeah. We are safe. Fede.
Yeah.
And so yeah. Let's kick off. What Fede, you're on the lead seat this
Mhm.
time.
Yeah.
What are you going to talk
Well,
about today?
there is a big problem with LLMs, and we all know about it. That is the context window, because as everybody knows, as we talked in the first workshop, every LLM has a different context window. We are used to work with OpenAI's LLMs and models like DaVinci or ChatGPT, and ChatGPT has a 4,000 token limit, and Claude announced last week that they are releasing, and we know because we have been trying it. Like there is a 100,000 tokens, so that is really a big improvement. But anyways, the problem with the token window is probably going to keep happening, because even though there is a much more bigger window, it probably won't be enough for every task we have to do. So what I'm going to try to do in this workshop is show first uh, I don't know, a SDK or a framework that is really popular right now that is called LangChain, and how to use this framework to solve this token window problem to do a specific task that is summarize a text. You can do this same thing if you have a big test and you need to ask questions. You can use the same framework and the same techniques, and it's probably going to be something similar, but we have to focus in one task. So we are going to do it with summarize.
Amazing. And apparently, I'm seeing here on the screen that you are sharing this new UI that we haven't explored. This is called the Google Colab, right?
Yeah, Google Colab is really popular between data science people, and I mean, with AI, it's really popular right now because it allows you to run Python code, and it allows you to share and collaborate with other people. So, and it's free also. So it's really popular, and probably most of the people know about this because every paper about the LLMs is showing maybe a collab or something like this. But there are some people that don't know it, so I'm going to do a quick intro just to present the tool, and then we go right into the workshop.
Okay, amazing.
Okay,
Yeah, go
let's do
ahead.
it. So
Yeah.
Colab, what is Colab? Colab is something Google provides us for free, and it's a kernel and a Python kernel where you can write Python code, but also you can do like text cells. So you can write about what you're about to do. So when presenting this to someone else, you can write and not only code. So you can be really explanatory, and it's really good for sharing. That is one of the really good features of Colab, that is sharing. You can share this notebook with anybody, and everybody can write and make comments. So it's a collaborative tool. And other good feature that Google provides us is you can use GPUs. So you can change the runtime here, and you can use a GPU for free. That is super important because not everybody has access to GPUs. And also you can, to organize, you can do this table of contents. And what is the table of contents is you just write cell codes like text codes, and you just use it this tags, this markdown, to organize your code and your cells. You can also view in runtime all the variables that are in memory. That is super important for debugging. And you have this virtual machine that they provide. It's not a virtual machine, but we can think about it like this. You have a file system, and you can store files here. Your problem, when you stop using it, everything gets lost, but you can connect it to Google Drive, so you can persist on time. Okay, let's write into. So text cells, everybody knows what is text, but you can use Markdown here to organize and show different stuff. You can also use LaTeX, super important to show formulas and math. And you can not only run Python code, but you can use shell commands to interact with the virtual machine that you're using. Like here, we can run to show the ls. And also, it comes pre-installed with a lot of Python libraries that are super useful. So you have all these libraries pre-installed, and you can use them for free, obviously. So let's go. Also, you have magic commands. What are magic commands? This is something that came from Jupyter notebooks, because this is a Jupyter notebook running on a Google environment. And magic commands allows you to do a lot of stuff, like time, how long it takes the cell to execute. Like here, time. We are running sleep for 3 seconds, and this took 3 seconds. You can run HTML. And you can also use this magic command to show all the other magic commands. So it's super helpful to have this. Also, you can run Python code, obviously, because this is the most important thing. Here, I'm going to show you, we have like a global environment. You have in memory these variables, and they're going to show, can be used in any cells during the use of the notebook. And you can see here that you have these variables working here, both the type, the content, everything you have here. And as you see, I'm going to use these variables in other cell to do another thing that is super cool of Python and Jupyter notebooks and Colab, that you can, on the same notebook, you can see the output of what you're seeing. In this case, it's an image. You can copy this image of whatever you want. Super useful. And what's important here is that the scope of these variables can be used in any cell of the rest of the code. This is our super quick intro to Colab. I hope everybody understood. If there is any question, just ask on the chat and we'll try to answer.
I feel that this is a copy from the Wolfram Alpha, actually from the Wolfram app that you can run on your desktop that has been there for I believe 20 years. From Wolfram, right?
It's not a copy from that. It's just implementation of Jupyter notebooks that's been running a lot of time also, but it's kind of the same idea.
Yeah.
Okay, let's dive in. What is LangChain? LangChain is a framework that is being developed like in January of the year, and the idea of this is to give you abstractions to interact with LLMs. That's basically the whole idea. You have connectors to different databases, to different data sources. You have integration with all the most famous LLMs like Claude, OpenAI, Llama, whatever you want. It's super helpful and it's really big. So I won't be able to show everything here, but you can dive into on there's repo and see what they got there. That's super impressive. So I'm going to install Orwin here. I'm just using LangChain and OpenAI for the demo. This one allows me to use the OpenAI key that I have stored on my Google Drive. It connects me to Google Drive. That's super important. So also, you can connect your environment to Google Drive. So here I have the file system that's mounted on my virtual machine. And when I connect it to the Google Drive to get the environment file, to get the OpenAI key, it's going to show here my connection to my personal drive.
And one question, Fede. If you connect with your Google Drive, what can you do after that? I mean, can you access those files? Maybe write as
You
CSP?
can you can do whatever you want in your drives, like accessing your drive like a file system. You just mount it here, and you can write files, read files, copy files, whatever you want.
Amazing. So you can use it as a file system.
Exactly. This Colab provides you a file system that is volatile, so it will be deleted. Everything you do here will disappear. But if you mount your Google Drive, you can store it things here there, and you won't lose them.
Makes sense. Amazing.
Okay. This is my drive here. Okay.
Okay.
So let's continue. The first thing we talked about in the first workshop was prompting. Prompting is the only way to communicate with LLMs. I mean, not multimodal like images, but from text to text, it's prompting. And LangChain provides you a framework to write these prompts as templates. So I'm going to import everything I need here, and I'm going to define my model. In this case, I'm going to work with completion model DaVinci. And here you see the template. The template here is just a string, and you can use a placeholder to use variables to use a generic prompt. And when I create the object that is a prompt template, I introduce just the text, the string, and define all the variables with the names of the placeholders. So when I create this object that is a prompt template, I can use the prompt template to interact with the LLM. In this case, I'm going to ask a couple of questions because I have the variables that are make a list of amount of something, work history events related to some topic. So I'm going to make three items on war and 10 items on health. And here's the next step. You create a chain. What is a chain? A chain is like the
Fede,
base. Yeah.
before we continue with the chain, the prompt template is a way for you to fill up, because we saw prompts in the first and second, but there you have something with curly brackets, right? And apparently this prompt template, what it does is to replace those curly brackets. How
Exactly.
does that work?
You can do the same as what I'm going to do with LangChain with
Hmm.
code, as because this LangChain is an implementation and makes everything easy for you. In this case, what we do in the template is we have the prompt here, and these placeholders are what the parts that we want to change on the prompt to make it generic, right? So when I define the prompt template, I give you this string that is the prompt and the variables that I'm going to replace. So
Okay,
when I
amazing.
want to use it, I call on this prompt just using the variables.
Oh, amazing. Okay, okay. I see the code bit.
Okay, in this case, I'm going to create a chain that is super simple, that it just has the prompt and the model that I'm going to use, this one, DaVinci. And when I execute this chain by calling the object chain and running it, in this case, I'm looping through this list and I'm trying to create the prompt. So in this case, like here is calling OpenAI DaVinci model and sending, make a list of 3 work history events related to war. Here are these ones. And then calling it again with the second part. Make a list of 10 work history events related to health. Okay, so this is super simple, but this is like the base for everything in LangChain. You have a prompt and you have a chain that you can use. These chains can be so useful, like adding tools like Wolfram Alpha or Google Search. You can do a lot of things with this. This is like the simplest one.
That's
You can also
amazing.
see,
It's like having a function that takes a topic and an amount of items that you want, and then it generates them using LLM. So it's what we saw in the previous workshop, but
yeah, it's
yeah,
the same. You're having function that is being used by calling an LLM. You
yeah,
define this function on the LLM, but LangChain provides you a framework to organize this. That's it. It's just an organization and abstraction you can repeat and you can share, and everybody's going to understand. On the other way, you have to use like the code for calling HAPI, sending the prompt, and replacing all this stuff. This is solved by changing LangChain.
okay.
You can also serialize the prompt like this. I'm going to save this prompt and it's going to appear here on the file system. It takes some time because I have to refresh, but there it is. And you can see like this is serialization of the prompt. You have the input variables. You can also have an output parser. You can tell what the function on the LLM is going to return, and you can parse it. It's super helpful. Here we're going to continue with the chat model. First, we use the DaVinci, that is a completion model. Then OpenAI released the 3.5 and changed the format of the calling to make it chat. So in the chat format, you have three kind of messages. You have like system messages, AI messages, and human messages. So when you call the chat GPT completion of chat model, you have to send this message. You can set just a human message. You don't need the system message. You don't need the AI message. But when you call it, you have to make a list of all the messages you want and call it from these messages. Okay. So in this case, I'm going to create a template for a system message that is telling, okay, read the following text and make a list of recommendations to correct this, proofread, syntax, and everything. And the human template is just going to be a variable, user input, just that. So when I call the create the chat template from this, it's going to have a system message that is going to be this one, and a user message that is going to be what we used to call the function. So with this chat model, I create a new chain like we did before with the completion model, and I'm going to run it. It takes some
Fede,
time.
while it loads, when you said that you have there a system message and then another message, you could add more things, right? Because that the
Exactly.
line 20 accepts as many messages as you want, right?
Here, you create the prompt template from messages here, so you have a list of messages. You can add AI whatever. Let's check it out on the playground. On the playground, you have the system message, the user message, and you can add this message assistant, user assistant. You can do exactly the same. You can
Okay,
make a list of messages and send it to the model from here from LangChain.
makes
So
sense.
here was the run. Here is the answer. Like every time you use the LLM, you get these kind of answers. Here you have like on text, you can parse it from a JSON or whatever you want. So this is the super simple one. And let's dive into on the topic of this workshop, that is summarization, right? In this case, summarization is the way that we can show what we can do to solve the problem of having too much text to enter on a context window. So we have been working with last week congressional hearings on AI, and it was 2 hours and a half, I think, of conversation on AI topic, and everybody wants to know quickly what everybody was talking about, what's the main topics, who was talking, who was saying what. So what we did was create a transcription of this text, but it was super long. It was, as I said, 2 hours and a half, and when we try to load this, it's impossible to load it on OpenAI's APIs. So to create a summary of this, we have to do something to avoid this problem. In this case, I'm going to use a library that's called TtoKen that is super helpful for counting the tokens that are going to be used. This library works with OpenAI models, but you can count the token for other models on some similar ways. In this case, the token provides you like encoding for DaVinci that is different than the encoding for GPT Turbo. This encoding is called P50K for DaVinci, but we are going to use GPT Turbo, and you have the encoding that is CL11 key. Okay. We're going to load this transcript from file, and we're going to count how many tokens are on it. As you see, we have 40,000 tokens, so it's impossible to shove this inside GPT OpenAI APIs.
Fede,
And yeah,
sorry to interrupt you, but when you check these encodings, what you're doing there is to split the text into tokens, right?
exactly. What this library is using is taking the text that I'm going to try to encode here.
Hmm.
And it's counting exactly that. It's encoding into token. The same token is using the same model
Yeah,
that uses GPT-4.2. And so we know that for this model, this text has this amount of tokens.
okay, amazing. And then after that, you loaded the file from your drive, the drive that you connected before.
Exactly. This was the drive mounted here. This is
Okay,
my drive, and it's a folder called transcript, and it's a file, a TXT file.
that's amazing because that's the same command that you will use to read a file in your file system on your local machine, let's say.
Exactly.
Yeah,
This is pure Python, and this is the mounted drive. So it's like having this drive on my machine.
amazing.
Okay, let's continue. What we do here is we have this loaded text on this was a Python file read. So we have the whole text on a variable here text. And what we were trying to do, and LangChain provides this method that's super helpful and super great, is split this text in smaller chunks, right? LangChain gives us this recursive character text splitter, but they also have more splitters, like one for Python that splits different. It splits in classes and methods and all at different Python like tags. And we have like another splitter for, I think, for PDF. There are a lot of splitters. In this case, I'm going to use this one that is for text. That what this is going to do is splitting the text that I provide in different chunks. In this case, I'm going to use 2000 tokens. And what is good here is that you can use whatever function you want to count those, what this chunk is going to be. In this case, I'm using this token len function that I created previously. That is this one here. What this does is receive a text and return the amount of tokens. So I'm using this function that I created to split the text. And what this splitter does is trying to find different strings inside the text to use as splitter. So it's going to split by double break length, but if this size from double break is greater than this chunk size, it's going to be split by the chunk size. If not, it's going to split by the separator. In this case, I'm going to use 2000. Oh, sorry, I didn't import this. In this case, I'm going to use 2000 tokens because I know that my model has 4000 tokens and that my answer is not going to be super big. But you can work like your specific problem, like changing this and make it trial and error of the size you want to find. In this case, I'm going to use 2000 tokens, and when I split it, I get 24 splits. These are the chunks that I split from that function, right? And
Fede,
if
one
we,
question.
yeah,
You had an error before because apparently you can run these blocks and not run some of them. That makes
exactly.
sense.
Yes, that makes sense because you run these blocks by pressing Shift Enter.
Yeah.
and you can skip one if you want. But what happened there was that I tried to run this recursive characters text splitter, and it wasn't
Mhm.
loaded on memory yet. So give me
Oh,
error.
makes sense.
This line of code, what does is exactly that. It imports this method from this part of the library,
Yeah.
so it loads into memory, so it can be used.
Okay.
Here we have 24 chunks, and you see that we put like a chunk size of 2000, but none of the chunks are 2000. What happened here is that the biggest one with double breaklines or with single breakline was smaller than the 2000 tokens. So it didn't need the biggest the token, the chunk size. It uses the separators.
You're
But
using
yeah,
those separators because the file that you're using as a source has the messages of the, because we are summarizing this transcript, right, of this meeting. So the messages
exactly.
are separated by those lines, on those breakpoints.
Those separators are being used because those are most common use separator for TX files. In this
Okay.
case, this file, we can see it, it's kind of big, but as you can see here, we have the file and it has the break lines, and that's what is using to break.
Okay.
But if you change the size, like 1000, we're going to see that we have more chunks, and it also didn't give exactly the 1000. It's just an approximation of the chunks that you want. This parameter that I've been commenting here is because I'm not using it in this case, but it's super important to know that when you are trying to get some context from text, maybe catching it exactly by some point, it's going to split the context in the some important information by the middle. So this overlap allows you to keep some overlap between each chunk. So when the first chunk ends on character bound sounds, I suppose, the second chunk is going to have some information of the last part of the previous chunk. This overlap allows you to, uh, in cases where information is might be no super separated, allows you to have chunks that are overlapping. This is trial and error. You have to see it on your specific problem, but it's useful to have this.
I guess that works if, let's say that you have a conversation, right, and then you have these
Mhm.
windows of 1,000 chunks or 2,000 tokens that you are defining there. Maybe there is some context or some flow of the conversation that could be lost between chunks. So the overlap
Mhm.
works for that, right? To overlap those
Exactly.
chunks, and so you don't lose the flow of the conversation.
Exactly. It's exactly
Okay.
for that. When you have some information that get lost because it's split by the middle, it uses that overlapping to make it that information flow to the LLM. Well, so let's continue. I have the chunks now. What do I do with all these chunks? LangChain provides you like documents method to make an object that contains these chunks in case text, but it can be any kind of origin like PDF or whatever you need. In this case, what I'm doing is creating a list of document objects that has these chunks. The document object has not only the text that is page content here, but you can add some metadata there. So this metadata allows you to add whatever you want to each of the documents. So you can relate other stuff to the text. Like in this case, I'm not going to do it, but I might extract the timestamp. As you saw, this was a conversation with timestamp. I can extract the timestamp and put it on metadata, so I can then query that metadata to see on what part of the video is that's part of the text or whatever you need to do. So I have a list of documents here created, and we can see here I'm going to add some metadata to that document. I'm just going to doc number one, and here is the first page of the first document of what are my chunks is This is the text, right? So we use LLM again, model ChatGPT Turbo. That is the most useful, not having GPT-4. Okay, and we came to the first technique that LangChain provide us, and it's a technique that you can implement by yourself. But LangChain give you like the framework to work with it without needing to do all the repetitive part here. So, what is MapReduce? Imagine that you have a really large text. This is the one of the transcription, and what you do with MapReduce is separated the text in different chunks, and for that chunk you make like a summary, or you can extract notes or whatever what you need here, and then with all the summaries you call again the LLM, and you input all that summaries and say, okay, I have all the summaries, create a summary from the summaries, and that provides you a final summary that includes all the information from the other summaries. That is MapReduce. The pro here is that since each chunk is independent, you can run all this in parallel. So it might be a lot faster than other methods. So I have, like, imagine 50 chunks. I can send all the 50 chunks at the same time and get the response super fast. The problem here is that you might lose some information doing this map reduce. So when you extract a summary from the summary, some information might get lost. But let's see how this works with LangChain. I just load the summary change, and I'm telling you, okay, this is a map reduce. This verbose true, what allows me to see here for you is how it's working inside. So this is how the chain works. It starts by saying, okay, this is a prompt that I'm going to send. First, write a concise summary of this chunk. This is the chunk. It's super long here. You can see it, but it goes for to the right. But and then after that, it's going to send another prompt that is, okay, write the concise summary of the following. That is the second part. Here it's stopped at 9 minutes 5 seconds. Mine means 7 minutes. Okay, and after sending all that, you have here the last part. These are the um, the summaries of the previous parts, and I need a concise summary of this part. And the finished chain is this one. This is the answer, final answer. Okay, this is the final summary, and it's super short and includes all the parts of the chunks.
One question, Fede. So going back a little bit, what you did
Yeah.
is to create these chunks of 2,000 tokens. Then you selected just the first two, right, or the later
In
two?
this case, I selected the first two to, for time sake, because if I run
Yeah,
with all the chunks, it's going to take a lot. But here you can run it for all the chunks. It just was a time
makes
sake
sense.
problem.
But you just loaded two, and then you summarized one of those, and then the other, and then you summarized the combination of those two. That's the
Exactly.
idea.
All that was done just by calling this method. So
Okay.
that's why LangChain is good, because you can do this by yourself, but you have to write all the logic here. Like, first do this, go through every part and do the summary and store those summaries, and then with those summaries call it again to make the final summary. This just
Okay.
makes your life so much easier. In just one line, I did all that.
Okay. And can we see the finished product? Let's say in because
Sure.
can you
Here
copy it
you
or
have. What do you want to do with this?
no? Just to see it in several lines because that's quite difficult to read.
Okay.
Maybe.
I'm going to run it again here. So let's, because I just printed.
Okay.
It's going to run again.
And what? Sorry, but summarizing and maybe somebody showing later. Here we're calling this API from OpenAI, and we are using LangChain to connect our data, let's say, or chunks of your
Mm-hmm.
data with OpenAI's GPT library, this GPT 3.5 Turbo, and we are summarizing, making this long text into a smaller text that hopefully contains all the context, right, in a more concise way, concise form.
Exactly.
Okay.
So here you have like the text of the answer.
Okay.
And okay, this is just the first part of it here because I just used two documents, but you have like a summary of what you said. Um, as you said, when I'm calling this load summary change, I'm using this variable that has the model that I'm going to use
Okay.
and the kind of method that I want to use, and in case by this MapReduce. That's all I need.
Nice.
But now I'm going to show you the other cool part that we can use here is we can see the intermediate here on this with this verbose true, we just see the prompts. We don't get the final result of each chunk, but we can get those. So we can do the same change, but we can use this parameter to get all the intermediate part. So if in case you need, maybe you need a final summary, but you might find useful to have the intermediate summaries, so you can get those two. You don't lose it on the work. So let's wait a couple of seconds because it's going to take some time. Is there any question?
No, apparently no. We had a question about if the workshop was being recorded, and yeah, we
Okay.
are recording it, and also, guys, you can also see it after we finish. You can do a recap on our channel, on our Leniolabs channel. Also, you can see the two previous workshops. The first one we talked about just prompting 101, the basic of prompting, and in the second workshop, we discussed on how to use AI as a general. We used ChatGPT. We also used Microsoft. What was the name? Copilot.
Uh,
Yeah, that's the
Copilot,
name.
yeah.
Yeah, Microsoft Copilot to help us develop during develop time on our local machines, and then we use the ChatGPT um, APIs to develop some of the solutions.
Yeah, the
But
idea
yeah,
of this
continue.
workshop is to build on the other ones. So from this, probably the next workshop is going to include some of this stuff or not, but the idea is that we're going to build on top of the other ones. Okay, here you have what I talked to you about. You have the intermediate parts. This is the output text. This is the you get the dictionary with different parts. The output text is the final result. Okay, but you also have these intermediate steps, and you can see each one. Like this is the summary of the first chunk. This is the summary of the second chunk, and so on. You have all the summaries, and all these summaries was sent to get this final summary. Okay, so it might be super useful to have those because maybe you need to explore your problem. You're trying out if this works or not. You see if the different summaries make sense, and you may also need this not a final summary but different summaries, and you can use those.
Amazing.
Another method, another method that is good for this is refine. What does refine do? Refine separate all the chunks, but instead of doing all but separate, refine what you do is you do a first summary, and you then ask the LLM to you have that summary and make it better using the new context. So imagine you have I make a prompt that says make a summary of this chunk of text. Okay, and then I send that summary to the LLM saying, okay, I have this summary and I also have this new information. Adjust what this summary had with the new information and make it better. That's it was refined. The problem here is that since you build on top of the other one, you can't run it parallel. So it's going to take a lot of more time than the other one. But since you are having all the summaries being refined, you might get better results than with MapReduce. It depends on your problem, a specific problem, but I like this method better. In this case, we're going to do the same, but changing the type, in this case, refine. And you see the first one was, right, you can see summary. And the other ones we're going to see is, I have this summary and make it better with this new information. Let's wait a couple of seconds. So yeah, your job is to produce the final summary. We have provided an existing summary up to a certain point, and here is the summary that we have from the previous part. And we have the opportunity to refine existing summary only if needed, with some more context below. And this is the new part. This is the prompt that is being set. And this is something you can change and make it better for you. That another thing that we're going to see later, that we can change this prompt. This is the default prompt that brings LangChain to us, but we can use whatever prompt you want. We can override this prompt with our prompt to make it so that we have a special problem. We can use that. Going to make it up. So we have, I wanted to put 2 documents, but I forgot and put 4. It's going to take some time. But what you see here work is that what I told you, you have like the previous part that is being corrected with, let's see, we can see the difference. Here we have like artificial intelligence, and here is the see that this part is changing. Let me see if we can scroll to the right. As you see here, we have like this part that is not being changed, and this other part is not being changed, and maybe later transparent development of AI makes sense. He called for safeguard. So each chunk, it keeps some of the summary and then changes and adds stuff that in case during the hearing some element, this wasn't on the previous one, that was getting from the other part of the context. Okay, so this is the new output, the final output. Another summary, just another way to use it. In this case, for me, I like it better because I think to get better result with this refine, but the problem here is that it takes a lot of time.
Yeah. I mean, it makes several more queries, right?
No, it doesn't make more queries because on the other one, you have 20 chunks and you have 20 summaries and then a final summary. In this case, you have 20 chunks and it's also 20 calls because you have the first chunks, and then after that, with the result of the previous one, you get the new prompt. The problem here is you can do it on parallel. You have to wait for the first one to finish to start the second one, and then to start the third, you have to wait for the second one. On MapReduce, you don't have to wait. You can set all the chunks together on different calls, and they will come all together. And you have to wait for the 20 summaries to get the final one. You don't have to wait to run through from 1 to 10.
Okay.
That's the main difference. And here we have what I talked to you about. This, I'm going to change the prompt that we have here. This is your job
Fede,
is to find.
we have a question about this. Because when you refine, you are sending more
Mhm.
context, right? So
Exactly.
what happens if you bump into the context limit there?
Well,
Will LangChain split that into several chunks, or
no, it
should you handle
won't.
it? Oh, you won't do
You
it?
you should, yeah, you should handle it.
Oh, okay.
That if you find that problem, you will get an error, and it will say, okay, you went over the window limit, and you will have to go back and iterate and make a smaller chunks or try to find another way. What I would do is that I would make smaller chunks and try
Okay.
again. Just that. You have to when you try to here when you put the chunk size, you have to think on the size of what you're going to get out. So in this case, I put 2000. and I know that I have 2,000 token left to get the answer. So that's kind of a lot, but not depend on the problem. It might not be. So you have to make it smaller.
Okay. Yeah, great question that we had there.
Okay, so what I talked you about. This is the main. This is the default prompt. You have the produce final summary. This is the last one. Sorry. Here, write a concise summary of the following, and then the refined prompt is you have to produce the final summary. We have an existing summary to that part. Okay, so I'm going to change that. I don't want the summary like this. I want to extract notes, just bullet point notes. So this is the first prompt. I'm going to make a prompt template. Okay, like we see the first part, just a text with a string, sorry, with a placeholder for the variable. This is what I'm going to put of the chunk of information. And another prompt that is the refine prompt is the prompt that is going to be run after the first one. In this case, it's similar, but instead of doing summary, I just add this existing answer that is going to be the previous notes, okay? And I'm going to add the text that is going to be the new chunk. So let's run this. And you will see when we run this that instead of having a summary like this, we're going to get notes. Exactly. And you can do whatever you want here. Imagine that you don't need a summary, you need something else. You need to answer a question. There are templates for that also, answering question, but you can use this same method of mark reducing and refining because this works for big text. Exactly that. So you can use it for refining an answer, for summaries, for whatever you need to do with big text.
Amazing. I mean, so you can override the queries that they, I mean, the prompt templates that they already have built in the LangChain, or, yeah, framework.
Yeah, yeah, exactly. You can
And
overwrite it.
yeah, and yeah, following with I think what I said earlier. I mean, it's the same idea of what we saw in the previous workshop, that we use this as a function. So we are here, we are modifying the, let's say, the code of the function that comes in the
Mhm.
library. And yeah, this is all defined by natural language. We are using natural language to define the logic in what we want to do with the input text, for example.
That's it. That's the main thing. Is imagining using the LLM as a function that you put some parameters, an input, and you get an output. In this case, exactly what you did is that is changing the code of the function that comes with the framework. It's overwriting what you get. And this is the result we get. Instead of the summary, we get in nodes, like different nodes. In this case, we go to nodes only. And if we see intermediate steps, we're going to see that these are the nodes from the first part. Oh, sorry, the mouse is acting up. This is the nodes that it got from the first part. This is the goes from the second part. As you see, the nodes of the first part are being kept, and they're probably the same till some point. And the second node, it was modified to add with the new context. The LLM added more information, and this is great because you can see all the parts that are working on to do this. This is super helpful.
And so the final answer is that there you have the summary of the first three chunks, right? Just the first three chunks, and then you have there the topics on the before the
Exactly.
intermediate steps.
Yeah, this is the final. Here you have the final answer, the notes it got from the most important topics of the transcription, and this is the intermediate step that it got from each of the chunks.
Okay, amazing. And let's say that I wanted to, because those ideas for me are a lot to read. Could I, could could we get maybe that the notes are maybe 20 words long and no more than that? Can you
Sure,
modify the prompt to make that?
we can, yeah, exactly notes. Let's make it like in no in no, make it extract words and write it.
in no more than 20 words, let's say.
And okay, 12 words.
Okay, amazing. 30 words
Mm,
is it's a lot for me, but yeah, it's okay.
I'm going to change okay, let's do 20. I also think I'm going to change the refine. Mm, see if
Okay.
this works because it will probably take a lot of time or more time to see the prompt and see what what will be the best prompt. But let's try it like this.
Yeah, I mean, I just wanted to check if it's just a modification of this idea, and just the 20 word limit was, I mean, something to try on. But I mean, I want to see if we can change this and see how the system responds. I guess that if
Mhm.
anybody is using this collab, I mean, you can use it, guys, if you are there.
It didn't work. It didn't work as we thought. We have to put more thinking on the
Oh,
prompt because we didn't get 20 words here, obviously. But
okay.
I think that is like more concise, shorter. Maybe I don't know. You have to play with the prompt,
Yeah,
but you can do whatever you want. So you can change the prompt to see what fits your problem better.
yeah, makes sense. Makes
Okay,
sense.
that's it for all. We have more on this topic, and we'll probably continue on the next workshop. Maybe not like this, maybe on more case use and application using this and other techniques or to work with the context window. But I hope you have a good time and you learned something today.
Yeah, I mean, I haven't used LangChain a lot actually because
Mhm.
I'm more on the JavaScript side, as you saw in the previous meeting. But yeah, I will check it out. I believe that there is a JavaScript version of this library also.
Exactly. Let's go to the. I think that I put the link here to the repo here. This is LangChain, and I think there is okay. Here it is. Like there is a JavaScript version. Sorry, my mouse is acting up.
Okay, amazing.
Yeah,
Maybe we can use this in some edition of this workshop
sure.
to use it on the front end.
What's good about LangChain is not that it's making something that is impossible to do by yourself. It just makes your life easier. That's
Yeah,
it. It's gives you some order, some framework to work, and to make nicer code. Just that, because I can do whatever they did and do it by myself.
yeah.
But this makes it easier.
Yeah, I mean it's great. We have there a question from, yeah, from Cheque that says, can you recommend any YouTube channel or publication to follow AI news? I follow Fireship, but their videos make me nervous. Okay, yeah. I can recommend AI Explained. I love that
AI
channel.
explain is great. Yeah.
Yeah, that channel is amazing. I mean, the guy is pretty committed to this AI race. He has been, yeah, throwing videos every week for the past few months. It's not a new channel because he had videos from before, but yeah, now he has a lot of followers and he's picking up, and yeah, his videos are amazing. I mean, he doesn't stay on the just the fast of the AI world. He goes in deep and does a lot of experiments, and then he shows those experiments in his videos. So yeah, I can recommend that one.
I I don't have right now that is good for news. I have another one to recommend that I really like. It's not a news. It's not a news channel. It's just a guy that has been working with the AI for a long time,
Yeah.
and I really love his name. David Shapiro. Shapiro, I think. I'm
Oh,
not.
Dave Shapiro. Yeah.
Yeah, Dave Shapiro is his weight, and he's super good explaining a lot of different topics. And he's been working on training his own model. He's great. I recommend that channel also.
Yeah, he has also a lot of videos about some of the fuss around AI, right? And so if you
Exactly.
want to
Yep.
see things that are more in depth, or maybe if you want to see some science fiction around it, you can go and see it, because yeah, that channel is also great. He goes
He's
into a lot
been
of details
Yeah,
around it.
he's been using AI, and he showed how he's writing a novel and he's using AI and an assistant to work on his novel. So he's a guy that knows a lot and shows different practical uses of AI.
Amazing. Okay, so Fede, I guess that we are done for today.
Mhm.
We are probably going to come back next week with something around embeddings and some application for the front end. But
Yeah,
yeah,
using
we
vector, maybe vector databases to use to store those embeddings, and that's useful also.
yeah. Okay, thank you Fede again for this.
Thank you for your time,
Yeah,
and let's see you next week. Next week.
see you next week. Bye bye.
Okay, bye bye.